India's space journey over the last 12 years reflects the spirit of Vishwas, Vikas, and Jan Kalyan. Driven by Atmanirbhar Bharat, Make in India and the vision of Viksit Bharat 2047, the nation has emerged as a leading space power through landmark missions, indigenous technological capabilities, private sector participation, and expanding international partnerships. Space technology today supports governance, economic growth, national security, and citizen welfare, making it an essential component of India's development trajectory. Expanding India's space capability. India has significantly strengthened its scientific and technological capabilities through ambitious space missions, advanced launch vehicles and indigenous technologies. Lunar exploration. Chandrayaan-1, 2008, discovered water molecules on the Moon and provided crucial insights into the lunar surface and exosphere. Chandrayaan-2, 2019, generated high-resolution images of the lunar surface and significantly expanded scientific understanding of the Moon. Chandrayaan-3, 2023, made India the first country to achieve a soft landing near the lunar South Pole and the fourth nation to successfully soft land on the Moon. Scientific instruments on board Chandrayaan-3 confirmed the presence of sulfur through direct elemental analysis. Chandrayaan-4, 2027, aims to bring lunar samples back to Earth. UPSC-Chandrayaan-5, in collaboration with Japan, will explore water ice and volatile resources in permanently shadowed lunar regions. Interplanetary missions. Mars Orbiter Mission. Mangalyaan. India became the first country to reach Mars orbit on its maiden attempt and demonstrated cost-effective deep space mission capability. Venus Orbiter Mission, scheduled for 2028, the mission will study Venusian geology, atmosphere, and climate dynamics, expanding India's planetary exploration program. Solar and Space Science Missions. Aditya L1, India's first solar observatory placed at the Sun-Earth L1 Lagrange point, studies the solar corona, solar winds, and space weather, with over 27 TB of scientific data already released. AstroSat and ExpoSat, these missions have strengthened India's capabilities in multi-wavelength and X-ray astronomy, contributing to global scientific research. Human spaceflight and orbital infrastructure. Gaganyaan mission, India's first human spaceflight program, aims to send Indian astronauts into low Earth orbit, placing India among the few nations with independent human spaceflight capability. Axiom 4 mission, Group Captain Shubhanshu Shukla's participation provided valuable operational experience in astronaut training, microgravity research, and human spaceflight systems. Bharatiya Antariksh Station, BAS, India's planned space station, expected to begin with its first module by 2028, will support long-duration human missions and advanced scientific research. Space docking and advanced technologies. India achieved a major technological milestone through SpaceX, space docking experiment. India became the fourth nation after the USA, Russia, and China to demonstrate autonomous docking and undocking in space. Successful testing of the indigenous Bharatiya docking system enables future missions such as Gaganyaan, Chandrayaan-4 and Bharatiya Antariksh Station. Commercialization, expanding India's space economy. India's space economy is currently valued at around $8 billion and is expected to grow fivefold to $40 to $45 billion, raising India's share in the global space economy from 2 to 3% to nearly 8%. To boost commercialization, the government established New Space India Limited, NSIL, in 2019 for commercial utilization of ISRO technologies, and Indian National Space Promotion and Authorization Center, InSpace, in 2022 to promote and regulate private sector participation. These reforms have delivered strong results, with NSIL's revenue increasing from 321.77 Indian rupees crore in FY 2021 to 22 to 3,246.09 Indian rupees crore in FY 2024 to 25, reflecting growing global demand for Indian launch and satellite services. Private participation has expanded rapidly, as InSpace facilitated 71 technology transfers from ISRO to industries and startups, while private entities launched 18 satellites and flew 25 payloads through the PSLV Orbital Experimental Module (POEM) platform. Further reforms such as the approval of an Earth observation satellite constellation under the Public-Private Partnership (PPP) model and transfer of Small Satellite Launch Vehicle (SSLV) technology to Hindustan Aeronautics Limited (HAL) are creating a globally competitive and innovation-driven space ecosystem in India. Self-reliance in space transportation. India has achieved self-reliance in space transportation through the Polar Satellite Launch Vehicle (PSLV), Geosynchronous Satellite Launch Vehicle (GSLV), and Launch Vehicle ARC-3 (LVM-3), enabling the country to independently launch satellites for communication, navigation, Earth observation, and space exploration missions. To meet future requirements, the government has approved the Next Generation Launch Vehicle (NGLV), which will significantly enhance payload capacity and support ambitious missions such as human spaceflight, lunar exploration, and future space station operations. India is also expanding its launch infrastructure with a second spaceport at Kulaskarapatanam, Tamil Nadu, the Small Satellite Launch Vehicle (SSLV) complex, and the third launch pad at Sriharikota, strengthening the country's ability to undertake a larger number of launches every year. Simultaneously, the Indian Space Research Organisation (ISRO) is developing advanced propulsion technologies such as electric propulsion systems (EPS), upgraded cryogenic engines and semi-cryogenic systems, which will improve mission efficiency, reduce costs, and extend satellite life. A major focus is on reusable space transportation through the Reusable Launch Vehicle Technology Demonstrator (RLVTD) program, which has successfully demonstrated autonomous runway landings and is expected to reduce the cost of accessing space in the future. India's self-reliance has further deepened through indigenous technologies such as the Vikram 3201 space microprocessor and Kalpana 32 processor, reducing dependence on foreign electronic components and strengthening the country's technological sovereignty in the space sector. Global partnerships and space diplomacy. India's emergence as a major space power has been driven not only by indigenous achievements but also by strong international cooperation. Over the last decade, India has launched 399 foreign satellites and signed more than 300 space cooperation agreements with 61 countries and 5 multilateral organizations, enhancing its role as a trusted and responsible space partner. India has also strengthened regional cooperation through the BIMSTEC space program under its Neighborhood First policy, supporting disaster management, weather forecasting, satellite applications, and capacity building across South Asia. Some of India's most important collaborations include NASA, USA joint development of the NISR mission for Earth observation, climate monitoring, and disaster management. CNES, France partnership on the Trishna mission for monitoring agriculture, water resources, glaciers, and climate change. JAXA, Japan collaboration on Chandrayaan 5/Lupex for exploring lunar water and resources near the Moon's South Pole. Roscosmos, Russia support in astronaut training and human spaceflight technologies for the Gaganyaan mission. European Space Agency, ESA cooperation in future human spaceflight missions, astronaut training, and lunar exploration. Beyond these, India has expanded strategic space partnerships with Germany, Italy, Saudi Arabia, Mauritius, and Bhutan in areas such as Earth observation, satellite communication, navigation, research, and commercial space activities. India has also used space as an instrument of diplomacy through initiatives like the South Asia Satellite, GSAT-9, which provides communication, telemedicine, education, and disaster management services to neighboring countries. These partnerships have transformed India from a participant in global space activities into a key collaborator shaping the future of space exploration, scientific research, and sustainable development. Space technology for citizen welfare and national development. India's space program has increasingly focused on using technology for governance, development, and citizen welfare. NAVIC, Navigation with Indian constellation. India's indigenous navigation system provides accurate positioning and timing services across India and neighboring regions, supporting train tracking, vehicle monitoring, Aadhaar geotagging, logistics, public safety, and strategic self-reliance. Data-driven governance. Geospatial platforms and satellite imagery are helping ministries and state governments improve planning, monitoring, and implementation of schemes such as Mahatma Gandhi National Rural Employment Guarantee Act, MNREGA, Pradhan Mantri Gram Sadak Yojana, PMGSY, Pradhan Mantri Krishi Sinchayi Yojana, PMKSY, and Atal Mission for Rejuvenation and Urban Transformation, AMRIT. Food, water, and livelihood security. Satellite-based crop forecasting, drought assessment, yield estimation, and water resource monitoring through the National Hydrology Project and India Water Resources Information System, India WRIS, strengthen agricultural productivity and water management. Disaster management and early warning. Space-based systems provide real-time monitoring of cyclones, floods, landslides, forest fires, and other hazards through platforms such as the National Database for Emergency Management and Satellite-Aided Search and Rescue, SISR, improving preparedness and response. Support to coastal communities. Potential fishing zone, PFC, advisories help fishermen identify productive fishing areas, reducing fuel costs and search time, while indigenous distress alert transmitters, DATs, enhance safety at sea. Healthcare through telemedicine. ISRO's telemedicine network connects remote and high-altitude regions such as Ladakh, Siachen, and Jammu and Kashmir with specialist healthcare services, improving medical access in difficult terrains. Education through satellite connectivity. Under PM Vidya, educational content is delivered through 370 satellite-based television channels using GSAT satellites, extending quality learning opportunities to remote and underserved regions. Regional development through South Asia Satellite, GSAT-9. The satellite supports telemedicine, teleeducation, weather forecasting, disaster management, and communication services across neighboring countries, strengthening regional cooperation. Citizen-centric digital platforms, geoportals such as Bhavan, Unity, Meteorological and Oceanographic Satellite Data Archival Center, MOSDAC, and Visualization of Earth Observation Data and Archival System, VEDAS, provide satellite-derived information for weather forecasting, infrastructure monitoring, flood management, and digital governance. Through these applications, space technology has become a key enabler of inclusive development, strengthening governance, improving service delivery, and enhancing the quality of life for millions of citizens.